Hello, this is Jeremy Wilkey. Wanted to give you a quick update on our PSF2 spring conversion. So our system here is finally done. This was kind of the last piece of the puzzle. A lot of people are, well, I shouldn't say a lot, but there's some companies, of course, doing spring conversions now other than our company. And you know, that always is kind of interesting, just because you're curious to see how they've solved some of the other problems, you know, or how they've attempted to solve the problems. And the major hurdle with the PSF2 was not really putting a spring in it. That part of it was really easy, but it becomes an issue of, okay, what do you do with an open chamber separate function fork? So we've got good architecture, but without the twin chamber mechanism, there's a lot of potential for aeration of the oil. And let's say the coefficient of performance is pretty low from an expectation standpoint, and so all that stuff can be managed. I mean, the big thing is, of course, you got to change out the mid-valve pistons, and you know, all the things that people are kind of used to doing. So we add in a adjustable base valve. It's adjusted via a 4mm Allen head, and that's really nice. You know, again, no slip on the screwdriver, all that kind of stuff. But that also allows us to really kind of improve the pressure balance of the system, which is a key point to making this whole thing work. And then kind of the other part of it that you'll quickly run into if you attempt to test and validate it is that the stock bottoming control in the PSF2 is just completely inadequate. So I'm sure they're managing that by very high oil volumes. Of course, that creates additional issues. You're going to have harshness and braking bumps, and let's say a very progressive mid-stroke, which, you know, I mean, arguably some people are going to like, but I think measured as a whole is generally a pretty bad tuning method. So if you try to get the oil levels down to where, let's say, the performance is going to be good in the mid-stroke, then bottoming control is pretty much absent. So we created a speed-sensitive bottoming control utilizing the base valve and some new hardware. It's very similar to all the data we've learned about with the 4CS asymmetrical system. And one of the last pieces of the puzzle is we needed to make a new mid-valve tap. So anyway, we're basically shortening up the cartridge rod, installing a new rebound adjustment mechanism and a new base valve or mid-valve tap, excuse me. Not pictured in this because it's still prototype hardware. The kit is going to come with a new fork cap. We've got a really cool design, interpolated top, very lightweight, and that way we can get as much oil in the fork as we can or as possible without, let's say, adding the air spring, because we now have additional volume above the top of the cartridge. And those are all key details to making this thing work. Interestingly enough, even though we're putting that spring back in, and our system here is pretty light, especially with that new fork cap. So anyway, that's pretty much the technical overview. Thank you very much for watching this.